name is Elliot Koo, and I would like to welcome you to the 9th episode of Histo Helpers. Today I will discuss the histological events of the lymphatic system. Together, let's 1. Differentiate diffuse and nodular lymphoid tissue, 2. Recognize common and distinguishing features of palatine and pharyngeal tonsils, and finally 3. Recognize common and distinguishing features of a lymph node, thymus, and spleen. We begin at slide 246, which is a cross-sectional view of the appendix stained with H&E. First, we're going to locate a primary lymphoid nodule seen at the yellow arrow. These are nodules filled with lymphocytes, but they lack a germinal center. Here, the green circles are secondary lymphoid nodules. Secondary lymphoid nodules have germinal centers, which can be seen at the blue arrows. Please note that mature B lymphocytes are the predominant cell in the germinal center. Remember that B lymphocytes, or B cells, undergo maturation in the bone marrow. There is also diffuse lymphoid tissue seen here at the red arrow, which is loose connective tissue between the nodules composed mostly of lymphocytes and other immunologically active cells of the lymphatic system. Let us now move to the tonsils. The tonsils are a type of mucosa-associated lymphoid tissue, also known as MALT, which are composed of lymphoid tissue aggregates and nodules. Please note that you must be able to distinguish between the palatine tonsil and the pharyngeal tonsil. Don't you worry though, I'm here to help. This is slide 231, which is a cross-section of the palatine tonsil stained with H&E. As in the previous slide, you can also find primary lymphoid nodules circled in red, and secondary lymphoid nodules with their germinal centers circled in yellow. The crypts of the tonsil, seen here at the pointer, are a space to increase the surface area between the lymphoid tissue and the environment. The defining feature of the palatine tonsil from the pharyngeal tonsil is the stratified squamous epithelium seen here at the blue arrows. We are now viewing slide 91, a cross-sectional view of the pharyngeal tonsil stained with H&E. The defining feature in the pharyngeal tonsil are the patches of pseudostratified columnar epithelium. There may also be interspersed stratified squamous epithelium. Again, we can identify primary nodules and secondary lymphoid nodules here with their germinal center. We can see now the mantle zone at the tip of the yellow arrow, which looks like a cap of more densely packed lymphoid tissue around the germinal center. The mantle zone contains both T and B cells, but is richer in B lymphocytes. T cells undergo maturation in the thymus, which we will take a look at in just a hot minute. I now challenge you to look at slides 331 and 332 to practice your identification skills. We are now viewing slide 228, a lymph node stained with H&E. It is a bean-shaped structure ensheathed in a dense, irregular connective tissue known as a capsule, which can be seen here at the tip of the blue arrow. Lymph nodes are divided into an outer cortex here and an inner medulla seen here. This section was sliced a little off-center. Within the cortex, we can see both primary and secondary lymphoid nodules. The cortex receives lymph from the afferent lymphatic vessels, which would be seen in this area, yet the afferents cannot be seen clearly in this slide. Please take a look at slide 89 to see the afferent lymphatics. The afferent lymphatics carry lymph, antigens, and circulating lymphocytes to the lymph nodes. Many B and T lymphocytes from the blood can also directly enter the lymph node and other important lymphoid tissues, which we will discuss, through the high endothelial venules, which are specialized postcapillary venules. Just beneath the capsule, we can see the subcapsular sinus seen at the yellow arrow, which first receives lymph from the afferents. The trabeculae, seen here at the tip of the red arrows, are invaginations of the dense, irregular connective tissue from the capsule. The space surrounding the trabeculae are known as the paratrabecular sinus, shown here at the green arrow. They surround the trabeculae which receive the lymph next. Now let's take a look at the medulla, which has medullary cords at the orange arrows, made up of dense, irregular connective tissue. The medullary cords are surrounded by medullary sinuses, seen here at the pointer. The subcapsular sinus, paratrabecular sinus, and the medullary sinuses drain the lymph and the lymphocytes through the lymph node towards the efferent lymphatic vessel, seen here at the teal arrow, which is located in an area known as the hilus of the lymph node here. Let me enlighten you with some treasured, clinically important knowledge. The subcapsular sinus of a lymph node is a very common site where the initial invasion and colonization of metastatic cancer cells occur during metastasis. Please take a look at slides 89, 333, and 303 to practice the identification of structures within the lymph node. Each slide may show you a better presentation of the specific structures that we have pointed out. We are now revisiting slide 229, which is a lymph node stained with silver. Again, the purpose of this slide is to identify the reticular fibers found throughout the lymph node here. Remember, reticular fibers are important for maintaining the structure of the lymph node. We are now viewing slide 230, which is a section of spleen stained with H&E. Similar to the lymph node, the spleen also has a capsule made up of dense, irregular connective tissue seen here at the tip of the Nantucket red arrow, as well as trabeculae seen here at the lime green arrow. We have now moved to a different part of the slide. The spleen is made up of two types of pulp, red pulp found throughout the spleen at the red arrow, and white pulp, making up the lymphoid nodules seen here at the white arrow. The white pulp contains a distinguishing feature of the spleen, the central arteriole seen here at the pink arrow. The central arteriole is surrounded by a periarteriolar lymphoid sheath, abbreviated PALS. The PALS is made up of mostly T lymphocytes. We have now zoomed in on the red pulp. Within the red pulp, we can find splenic cords seen here at the pointer. They are made up of dense, irregular connective tissue. Splenic cords are surrounded by splenic sinuses seen here at the pointer, similar to the lymph node sinuses. The function of the red pulp in the spleen is to recycle red blood cells, a process which is executed by macrophages. Lastly, we arrive at slide 227, which is a cross-section of thymus stained with H&E. Progenitor cell lymphoblasts originate in the bone marrow and then migrate to the thymus to differentiate into naive, non-activated T cells. Like other lymphoid tissues, the thymus is surrounded by a capsule, which is poorly preserved in this section. It can be seen at the orange arrow. The thymus is divided into lobules, outlined in seafoam green. The septa, seen here at the pink arrow, are the spaces between the thymus lobules. The thymus can be divided into a cortex and medulla. The cortex, seen here at the pointer, contains densely packed lymphocytes and stains more basophilic. The medulla is the lighter, loosely packed lymphocytes of the thymus. It is important to note that the cortex of the thymus contains a blood-thymus barrier. This is formed by 1. The continuous endothelial cells of the capillaries, 2. The basal lamina, and 3. Thymic epithelial cells with tight junctions. Pay close attention to the next structure, the Hassel's corpuscle seen here at the yellow arrow. This is the characteristic structure found within the medulla of the thymus. The Hassel's corpuscles are areas of thymic epithelial cells that are undergoing keratinization and degeneration within the medulla. That is an absolute wrap. Thank you for following me through this vital episode of Histo Helpers. Be sure to join us next time for episode 10 as you feast your knowledge on Digestive System 1 with Katho Joe Naz. Thanks for watching Histo Helpers, and remember, we're here to help.